I was talking yesterday, right? And it was a very good talk. Thank you, like whoever came yesterday. Thank you for coming today. Yeah, this topic is something that I really love. So even though I'm a long-time Pythonista, I really like languages in general. So yeah, I'm like here in Poland. I'm trying to learn some Polish. So dzień dobry. Before I was living in China, and I had the chance to learn some Chinese. So I can greet you and saying 大家好. That means like hello, hello everyone. Do we have any Chinese speaker here? No. Good. Do you have any Go language speaker? Like anyone coding Go? Oh, nice. Yeah. So there are a lot of Pythonistas kind of having a look at Go. Yeah, I'm one of those. So what I have to tell you about Go is that, damn, it's really, really boring. Yeah, we have a language conference. Everyone cares about language. Python is a great language. And Go is such a very, very boring language. Why the hell would I be here talking about it, right? Go was a language created, one of the creators is this guy, like he looks very sexy, doesn't he? Rob Pike. Yeah, this guy is like, yeah, I don't know if all of you know him, but yeah, he was working at Bell Labs at the time. They're like in mouse, Unix system. So yeah, he probably knows very well what he's doing. But they built this language Go. It isn't something like, Python is made for readability. There are projects like CP4E, like everyone needs to learn how to program. Python is a great language for that, great for education. A lot of universities use it to teach people how to program. And Go, no. Go is just that boring language, as I said. It's made to scale. It's made to support a lot of programmers working together in a team. So, and it's a modern language. And people ask me, so what does it mean to be a modern language? Go was created recently. It's a young language. It's like it was born just a few years ago, and it's popularizing just now. So it could benefit from things that exist today, that when Python was created in the 90s, there wasn't such thing. So we are in the internet time. Oh, sorry. Let's get back here. Okay, great. It's trying to update. Yeah, so Go was created in the internet time, right? We are every computer connected to the internet, and Go can benefit from these things. One of the things that makes Go modern is this concurrency primitives inbuilt in the language that, for example, Python doesn't have, and we need things like gevent and other tools, right? Twisted to write twisted code, not really Python code. And yeah, like Go comes with it. A lot of people start looking at Go because they want to see the concurrency features. Don't worry, I'm gonna show them. But yeah, so in my way of thinking about this, when I try to answer this question, like why would I bother and learn another? Then I have to again point to someone, this guy. He inspired and he changed my life. So Robert gave a keynote in PyCon 2007. And yeah, I've listened to this keynote, I don't know, more than 100 times. I remember several years ago I was driving, going to university, and I was listening it. Like I had it recorded and I was listening it over and over and over and over. And this keynote is a very, very packed keynote. There's a lot of information, a lot of cool issues that Robert raises there. And he's talking about computer programming literacy. So everyone goes to school and learn a set of things. So if you are for example, a mathematician, there are a set of things that every mathematician needs to know. When you're a programmer, this kind of things is not really clear. And he discusses this and he tries to define things. And one of the things that he tries to define is what is computer programming? And yeah, as we were having conversation here after last talk, yeah, friends there from OpenStack was mentioning that code reviews are about people. So you should focus on, okay, let's not try to, it's not just about the code, right? Maybe the code can be a little, yeah, not perfect, but let's focus on the people. And that's when Robert defines computer programming as to be close to the definition of rhetoric. And then he defines computer programming to be the art of communicating through symbols ideas about reality. And it's this definition that I take for computer programming. So whenever I sit to write some code, I have clear in my mind that this is about communicating things. And what do you need to communicate? You need to understand well the language. So learning a new language for me is not about syntax, right? It's not about you just go there and memorize that there is a for and this is how I write it. I need the curly braces here and there, and I need to break the line, and I need 4 spaces here and there. No, don't focus on that. Also, don't focus on repeating the old things that you already knew. So sometimes I see Python code, I look at that, and I say, oh, this looks like Java. And I know that a lot of people migrated from Java community to start writing Python code, and they use those heavy IDEs, and they try to write Python just like they used to do in Python, in Java, sorry. So they're gonna write one class file, and yeah, they're gonna repeat all the pattern. Don't do that, right? Learn the language, learn to be a Pythonista if you're learning Python. So learning a new language is about expanding your horizons, right? It's about understanding what else you can do now that you grasp a new language. Grasping this new language will let you express better your ideas. So I have here, for example, a set of questions. I'm from Brazil, right? So I speak Portuguese. I can ask you, entenderam? Yeah, maybe, yeah, you didn't. Do you understand? Yes. Me bailama. And in Polish, it's funny because when I show this to my friends, they actually kind of corrected me. I can ask, czy rozumiecie? But people will also understand if I just say rozumiecie, right? The cool thing here to notice is that in Portuguese, to ask a question, I just use intonation, nothing more. To do that in English, we swap the order of the verb or the auxiliary verb and the pronoun. And yeah, that's what we learn in grammar. In Chinese, it's very cool, like the last character there, yeah, no one can read that, right? But that the last character there, and I can teach you something, like every time you read some Chinese, if you see that, you know it's a question. You don't have to have the question mark. If you see that, it means a yes or no question. And the same with Polish, as I learned, if they taught me right, if you have this ch in the beginning of the sentence, it means introducing a yes or no question. And yeah, Polish is flexible when you can either have it or not and just use intonation. Super cool. I'll also show how Go is super cool. So I said it's boring, but it can also be very fun and addictive. And yeah, I'm addicted. Sometimes, like, the feeling that I had when I started looking at Go is very similar to when I started playing with Python. Yeah, I guess you all had this feeling already, unless there is someone very new to the community here. Is there anyone like that don't have really good experience with Python here? Yeah. So yeah, I can tell you that learning Python, you're gonna feel very happy. Python comes, for instance, with batteries included. So a lot of things you want to do is already there in the standard library. You can just get work done really quick, and it fits your brain. I remember when I was learning Python, I spent maybe one weekend going through the tutorial, and yeah, like I still remember, like today is, I don't know, a decade passed, and the memories, the number of things you need to memorize is so small that even if I don't write a Python program for months or whatever, I know that I'll go there back to the editor and okay, I know what to do. Like it's kind of obvious. And even if you don't know what you're doing, sometimes you want to call a method on some object, and it's yeah, the principle of least surprise, right? You just try whatever seems to be the right thing, and it is. So it fits your brain, and Go also fits your brain. Python has a great community. I'm so happy. I'm so happy to be here. I'm really enjoying this event. I hope you're also enjoying. And it's fantastic because Go is a new language, but the community is very positive. There are very good discussions in the mailing group. People are always available to accept, for example, your patches. I sometimes send some patches to the language. I send recently. I found some problems with the documentation, and it was very quickly, like in a matter of minutes, it was changed and accepted, and now it's like live. So it's great. So yeah, let's cut the crap, and I'm gonna show you something that runs straight from my browser. So this is a Go program. I'm using my 4G because the Wi-Fi here is yeah, really tough. And just to show you the power of this thing, I'm querying right now. I just did a query to GitHub with this code to fetch popular repositories of projects in GitHub written in the language Go with a query of Python. So whatever has Python there in GitHub written in Go, these are the 3 most popular repositories. So yeah, these guys are writing Go and they probably like Python, like us. I can run it again, consume some kilobytes of my data plan. So just to show you that it works. Yeah, there will be some lot of code in this presentation. I don't really expect you to understand it like right away. Yeah, it's pretty tough, right? I have very short time. I don't really expect to teach you enough Go in this time, so sorry. But we have yeah, some tables there in the part with the sponsors, and we'll have I hope we are gonna have Go set up there. At least I have Go on my machine, so I invite you, if you wanna check it out, see in detail how this stuff works, come and see it in detail with me. Yeah, this is the photo of Pavel, like my friend is also working with me at base. So this is the invitation. Make sure if you're interested, come talk later. So now a little more about Go. Do you see well the code there? Like, is it too small or is okay? So you might have noticed, like, there are just curly braces and a lot of syntax. It's not like Python, right? That you just write. Had some code examples of Python when you write like 3 lines of very few characters and they do a lot of magic. In Go, yeah, sorry, there is no this. It's a lot like C, statically typed. So you put there the type information of everything you're using. Statically typed, but not like C in the sense that it infers the types. So most of the time you just declare what is the types of the input, the types of the output, and everything else. The compiler is smart enough to give the type for you, so you don't have to write it down. Yeah, it's very fast. It compiles to the platform's bytecode, so it doesn't need it doesn't have an interpreter, right? So you generate a binary in the end of the day, just like you had with C, C++. Very easy to distribute. So I have a personal project that runs on Windows. It's a chat client for blind people. So I kind of let them use this to connect with their friends on Facebook, on Google Talk. This is such an amazing project that I really love to work on. I hope to take some vacations in December and contribute a little more to this project. And I'm using PyInstaller to ship this on Windows. But I can tell you that it's really a pain. It's very hard. I have users reporting problems like some DLL problem on Windows and it doesn't work, and I'm like, I have no clue what to do. And yeah, if it was written in Go, of course, there would be other things to consider, but distributing is very easy. In the end of the day, you have a binary. You can cross-compile stuff, so you can code on a Mac and then ship code to Windows or Linux. So it's very, very, very cool. And Go has a lot of great tools, and this concurrency primitives you're going to see. The great tools, for instance, is this. I'm using this thing that I'm using for presentation is written in Go. We were talking also in the code reviews about PEP8, that we can execute it, and yeah, everyone can let the machine execute PEP8, and it works, right? And you don't have to do it yourself by visually inspecting code. I don't really agree with that because PEP 8 is a PEP, so it's English text. It's just some recommendations. It's not like a definitive thing. It's in some parts of PEP 8, they say, oh, maybe you can do like this, maybe you can do like that. So I really love the idea of PEP 8, of having this standardized code that everyone can read. Everyone writes Python, the code looks similar. With Go, they went one step further, and actually you have something called Go Font, or Go format. You can run this. This is a program that you run. It takes source code as input, and it produces a standardized output. So forget about discussing, PEP 8, no. Whenever you save a file, it's already standardized. It uses whatever format it is. So it doesn't matter really the format. What it matters is that you stop the useless conversation of how it should be. If it should be indented here, indented there, it should use this style, that style. Don't need to care about that. It's solved for you. So now I'm gonna show you like some parts of Go, so to give you an understanding of like how to build your programs. So let's go again. I'm gonna run this example. This is just like the closer to a hello world thing. So as you can see, like we can have Unicode. I don't have to say that it's strings are already like UTF encoded Unicode strings. So it understands like my Chinese ni hao, which is chest. So first part of that program. So this is a kind of 3 parts program, not very complicated. Can you see it well? I have a feeling that it's maybe too small. No? So first thing is a package. So when you start every program in Go, you're gonna declare in which package it is. It could be like in the example, it's on package main, or it's on package JSON, or AMQP. And the package in Go is very similar to the concept of package in Python. Is everyone familiar with packages in Python? Yeah? Yeah. Okay. And who is here familiar with the Zen of Python? Import this. Yeah? You should try on your Python interpreter, import this, and you're gonna see something written by Tim Peters, if I'm not wrong. And one of the things in the Zen of Python is that namespaces are a great idea. And yeah, I think like Go respects a lot of the things of the Zen of Python, sometimes even better than Python. So here is where you have the separation of namespaces. You declare something to be in a package, and then it's already, when you're gonna access something from another package, you have to put the package name in front of it, so you have like separated code. And the cool thing here, like the package can be split into multiple files, just like Python packages. And you don't have the concept of module. So you don't have something like, oh, everything that is in this file is already part of something. No. So you simply write your package, and normally, like for small programs, you're just gonna have the package main, and you're good to go. Imports. Imports, I think not a lot of surprise. You just say import and the name of the module you're trying to, the package, sorry, that you're trying to import. There is a nice thing. You can use the second format there. You can have a write import only once, and then you declare what packages you're importing. And this is similar to Python, right? You can say like import something, comma, something. Nice thing. You can pay attention that the import, you're not importing like identifier, you're importing a string. You have flexibility to do a lot of things with this. For instance, it's common practice in Go to give the name of your packages something like that, github.com, my GitHub account / the name of the project. And then there is a tool. Again, the tool comes in that can get your code, build it, run it, everything with all the dependencies. So that's also one of the great features. You can use this command go get. You say go get github.com Carvalho base CRM, and it's gonna download this package base CRM with all its dependencies. that can be in a Git repository, in a Mercurial repository, in a Bazaar repository, anywhere in the internet. This is great for open source. Exports, very interesting thing. In Python, we don't have this, right? We are big boys and we kind of respect. Okay, if this is supposed to be private, I hope no one is gonna play around with this. In Go, you declare public things as having the first letter uppercase, and private things have lowercase. So whenever you're looking at code someone else wrote in the middle of a big file, if you see there's something with capital letter, you know that it's exported. It's part of the public API. If it's lowercase, private method. Private, anything. This applies to several levels, to functions, methods, variable names, and so on. So yeah, forget about this underscore underscore pattern. Now you have real control of what is private, what is public. Yeah, I'm gonna skip through this. This is just like the basic types in Go. Unfortunately, like, we don't have much time, so I'm gonna go straight to the interesting things. Of course, we have like all the like very basic types, and we have some more modern things like maps or slices that work like lists in Python. Here's just a function. Not much surprise. It computes the maximum between two numbers. Not really that interesting. We have type definitions. So in Go, we don't have classes. You normally you have if you want to do something closer to a class, you use structs, similar to C, C++. But then the cool thing is that you can have methods on any type. So it's a language that is doing OO, only the good parts. So you have methods, but you don't have classes, key inheritance. No. So it gives you this, like, okay, it's a language, it's stupid like C, but it kind of opens your brain to think about how to do the same things you're doing in a different way. And then maybe you're gonna go back to Python and think, oh, maybe why do I do this a lot of try except that is very complicated? Maybe I should write this in a different way. Maybe like I learn in Go. You can also do multiple assignment, and functions can return multiple values, so a lot like Python. That example, GitHub API, very quick. You can go to GitHub's developer page and understand how the API works. Basically, you can send a GET request to these endpoint search repositories, passing a query. You can put in the query things like language, column, something, to filter repositories given language. That's using in that code. So we are going back to that code just to understand how it works in more detail. So here, the first thing we do to make that work, right? It was magic. You just saw 3 lines of results there. You trusted me that these are really the most popular repositories. You can go to GitHub interface and check that it really is. And then how do we do that, right? So first thing to get that right is, yeah, we built the URL as the API tells us how to do. Then get, very simple, HTTP package dot get. As you can see, the capital G, it's an exported name from the package. If it was a lowercase letter, I couldn't use. I'm on a different package. I cannot access internal stuff from someone else. And you see a lot of times in Go code, very explicit and boring error handling. So I wrote there a small helper function to check the error. It's just saying, like, okay, if the error is not new, then do this log fatal, which is equivalent of printing something, like logging something in the screen, and then exiting the program with error code 1. Yeah, so exactly, no exceptions. And we'll get there. Errors, remember. Thanks for the question. Yeah, I think if you want to like ask questions like in the middle, I don't mind. It would be good. So I have the same example in Python, and see how it would be so simpler. I kind of stripped down the building of the URL there because it's long, but yeah, it would be very simple, like 3 lines of code, and I got the same things as I did here. It's like, and here I'm not even showing you all the code, right? Yeah, but yeah, explicit is better than implicit. There's a lot of implicit magic going on here, and yeah, a lot of things can fail. So maybe you deploy this production, but you didn't really install requests, and you're using a third-party library, and you get an import error. What happens? I don't know, it fails in runtime, right? Sorry. Damn, okay, maybe you have requests. You put there your build script that downloads all the dependencies, cool. But then maybe you're offline, maybe you're in a conference, and there's no Wi-Fi. So sorry, your code, boom, exploded. You get some critical error message that you barely understand, and nothing was handled. Even more, maybe it worked, but maybe GitHub sent you some garbage, not a valid JSON, and you called .json and then boom, exploded. So first pattern, lesson learned with Go. Yeah, everyone makes mistakes, right? I'm trying my best, but yeah, we all make mistakes. I think we have to acknowledge that, and there are no exceptions. So yeah, as our friend there asked, yeah, there are no exceptions. We handle errors explicitly, and thanks to this possibility of returning multiple values, the pattern in Go is whenever a function can fail, can produce some error, it always returns the value that you're eventually interested in, and as a second return value, it returns an error. And then what you do with this error, you check it, right? You check it every time, and you handle it explicitly. Normally, the pattern is that as soon as you see some error, you break the flow of the program. So you just have a if there is some error, maybe your function returns this error forward and let the caller handle it. Or maybe you exit. Maybe you report this error to some service that you're tracking errors. So yeah, use multiple return values. I'm sometimes bringing this practice to Python. Instead of using exceptions, that I can raise some exception and then don't handle it in some caller, no, I explicitly return the error. So you can always check, and the error can be anything. It can be an exception in Python. So yeah, use errors. They are your friends. Don't be afraid of them. Handle them. So the other thing in that code was maybe we didn't have time to notice that there is something called defer. Oh, defer. What is that? So in Python there is something called context managers, and yeah, I hope you've seen something like this, right? You could write code like that in the middle. I suggest you don't, because with context managers you can use this keyword with and open a file and then iterate. Oh, and there's an indentation error there. Who saw that? It wouldn't run. So you could use this context manager to open a file, use this file, and doesn't matter if something went wrong during reading this file, you gracefully close the file after that block is done. Those two parts there are equivalent. And you might be thinking, like, we are using defer to close the body of the response, of the HTTP response you got from your call to get, right? But it's not really the same. Defer is basically saying, run this code after the function returns. So it's some piece of magic that lets you do some cleanup. So it is not limited to the scope of a with block, right? It's actually about the function scope. So for example, here I have like basically 4 lines. One prints A, then I defer a print to deferred one, then I print B, then I print defer 2. I would like to ask who here wants to tell me what would be the output when I click the run button? Someone? Please. Stand up and tell me the A, B, def1, def2. So let's run it. No, almost. A, B, deferred 2, deferred 1. Why? The deferred statements, they kind of accumulate in a stack. So they are executed in the opposite order as they are deferred, right? So this kind of is cool because when you are manage these things, it kind of builds this notion of the context, right? The function. Yeah, so the defer is about the function. Okay, so let's go to, like we have little time, I want to go to the interesting. So this is like the example of the JSON that GitHub sends us. There are a lot of things there. I'm just scared about the full name of the repository and the number of stars. That's what I was put. So how do we decode in Go? It's a modern language, right? It comes with JSON support built in, like Python now. But Python didn't have it, right? JSON support in the standard library, something new. What, Python 2.6, I think? So again, here I'm writing the search in Python. If I run it, produces the same output. Yeah, it does. Thanks. See, the tool is in Go, but it can also run Python code. Yeah. Nice. Yeah. This is, I was just picking on something, like I could write the same thing in Python using the standard library, but in Python we say there should be one way to do it. But I would like you to think that the way to do it is to use requests. It handles a lot of things that the standard library doesn't, like HTTPS and a lot of other things. So yeah, use requests. When we're using Python, we use requests. I just refactored that code, which was a big main function. I broke it into some functions. Like this is the same code. I just split that bunch of things into functions just to make it easier to grow. And how are we going to grow? There will be stages here. First one, I thought, okay, I can list the most popular repositories from GitHub. It was, yeah, maybe not that easy. It required writing a lot of lines, but it has error handling and it, yeah, behaves pretty well in most cases. It can even work with a 4G connection. And I thought, okay, so once we have the popular repositories, I think if a guy is really popular on GitHub, he has a lot of stars, he's probably a good coder and he might have other interesting projects that I want to look at. So I thought, okay, so now for each user or for each result that I get from popular repositories, I want to go to the GitHub account of that user and take the 3 most recent projects he pushed to. So I can have try to understand better this guy. Yeah, maybe he has something interesting for me and I want to work it or use it in my next project. So I'll skip through this. Like, let's talk about this in the corridor. Go has 4 loops. Yeah, only one. It's not like while, for, and a lot of things. No, you just learn 4. There's only 4, nothing more. Boring. So there are changes needed to the type definitions. See that in the type definitions, I just need to declare the parts of the JSON that I care about. Like all the rest I can ignore, and yeah, no problem. So even though statically typed language, blah, 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 I get statically typed JSON encoding, decoding, I still don't have the hassle of having, for example, to declare all the structure that is there in the JSON. So it's pretty flexible. Something popping. Close this. Okay, no more. Yeah, that's the problem. I have to use the 4G, so I'm kind of online when I didn't want to be. Okay, so the changes to require there were pretty minimal. I just like add some more information in the struct that I want. And now I have this function that fetches the recent user repositories given a user login. So, okay. This runs, right? So, given all this changes runs, and now it's gonna make. Now I have some logging, and as you could see, the pink. make it bigger. Yeah, so as you can see here, I'm logging. Oh, sorry. I'm logging the HTTP requests. So the first thing, like I had to do all the HTTP requests, get all the responses, and then I could build this new table with results. Remember that I had to do all the requests first, then print the results. Looks good. Now we can like use this program, explore who's doing great stuff on GitHub. Concurrency. I think you're all waiting to hear what Go gives us in terms of concurrency. There are two basic constructs that makes you write concurrent code very easily. Who here has experience with a G event? Yeah. So I really like G event because that's the concurrency model that I think that fits better in my brain. Yeah, sometimes when we're doing like CoffeeScript, JavaScript, we are like using this callback passing style, or I've written many years ago like twisted code and it was really hard to reason about. Not saying Twisted is a great piece of software, but some people have more like it's easier to understand some ways of doing things, and these things are really easy to understand, I believe. So what do you think this program is gonna print when I click run? Someone stand up and tell me, please. No one? Please, someone. Nothing. Wow. Yeah, pretty clever. This guy works with me. I love working with. Yeah. So why it printed nothing? How to use this? I didn't tell you anything, right? So first thing of concurrency in Go is this thing called Go routines. So Go routines are not threads. They are lightweight threads that the Go runtime schedules their execution for you. You can have many Go routines running simultaneously. I'll give an idea of how many. I was playing yesterday or the day before, and I just wanted to see, okay, my laptop, how many Go routines can I run simultaneously? And I thought, okay, 100. Yeah, like, try to run 100 threads in Java. You can do that. 1,000. Yeah. No, come on. 1 million. Yeah, it can do. Then I tried 10 million, and I'm like, I was running a very small program that was trying to update a counter. Like it sleeps 1 second and update a counter. So all these Go routines, they were trying to access the same place in memory using a mutex, like a lock. And so there's a lot of contention. So something that should take, if you think like parallel, concurrency is not parallelism. Think of parallel execution. If 1,000 people are sleeping for 1 second, it would take 1 second for everyone to finish sleeping. But since we had contention, running with 10 million Go routines, it would take for my laptop about 26 seconds to run and finish this program. And I could run 100 million Go routines simultaneously. It was consuming 2.5 gigs of RAM, and I think here I have like 16, so it was okay. But I just didn't see it finish because maybe it would take like half an hour because of contention. But still, like, you can just, for example, you use this for serving HTTP requests. So whenever you get a request, like a new request, you can spawn a new Go routine, very cheap, and you can serve 100 million, imagine, requests simultaneously. So the problem of that code there is that you started a new Go routine and then you finish your program, right? You just, when the main function ends, it's the end of your program. The program exited before you had time to run whatever was in that Go routine. So you need to, let's see, okay, we have some more minutes. You have to, well, one solution, okay, let's sleep for a second. Now you see, and then 1 second later the program exits. Why sleep for 1 second? Let's sleep for 1 nanosecond because I'm not really tired now. I'll run it again and boom. The program exits after 1 nanosecond and you still see the message. Why? Because the call to sleep blocks. So it sends the control back to the Go scheduler. Then it has time to say, okay, now it's time to run the other Go routine, the one that is going to print. So you see it. And then the program exits. Don't do that. Don't do that because, I don't know, who here uses Selenium for doing tests on the web? We're web developers, right? Yeah. I don't use Selenium now, but a lot of years ago, I was working on a big project and we used Selenium. And at some point, yeah, we couldn't use it anymore because we had the tests that were sleeping and waiting for something to happen. And that was a big mess. It doesn't work. So you have to communicate. When you start a lot of Go routines, you need communication. And the way to communicate with Go is using channels. Channels is this very simple concept. Imagine you have here like a big tube or a telephone, and you say something here, and someone listens on the other side. And it's a bidirectional channel, so I can get the response to the same channel. And that's how we make this code run without sleeping. We create a channel. In this case, I'm creating a channel of Boolean, so typed language. And I just, this is a closure, right? Cool. It's a closure. I can reference things from outside the function, inside the function. And yeah, it's remembered, everything works fine. So I can use this done channel to notify when I'm done. So I start a new Go routine, and whenever it finishes what it has to do, it says, okay, I'm done. And then what I do, I just start listening and say, okay, whenever you're done, finish the program. Boom. We are going to have talks here about asynchronous things and how to do concurrency in Python. I think this is really messy. I look at what we have in Python 3. I'm really sad because I cannot use this UD from and these new libraries. Sorry, Guido, like this is really a mess, and yeah, I cannot use that. So, cool thing about the channel is the communication. There was nothing in that program that talk about booleans, right? So like here I could say a done false, and it works as well. Right? There's nothing special about done true or false. It's just about receiving the message. Whenever you receive the message, you know that it's done. So I can use a struct, an empty struct. This takes 0 bytes in memory. 0, really 0. And there is no boxing like Python. It doesn't convert to a Py object in C, nothing. Okay, so it's 0 bytes in memory. And I just used the channel to communicate. So I had the same thing. Now I created a channel of 0 bytes. And I just say that it's done, and then it's done. Great. The communication, the receiving of the message is the important thing there. The channel has a size, but the things contained in the channel have no size. So the channel is, I think, 4 bytes, if I'm not wrong. So it's 4 bytes for the channel, and then with the other case, you had the 4 bytes for the channel plus the byte for the contained type for a Boolean, right? In this case, a 1 byte. No, but there was a transfer. You block listening. Yeah. Yeah. For example, you can have like a HTTP request, which is empty. But there are still the headers there, right? You have the headers, but the body is empty. And for example, a head request, it by definition is like the get, but empty, right? No body. You don't want the body as a response, but you still get the headers and so on. So you know there was communication. You can still increment your hit counter or something like this with a head request, right? Last part of this, and yeah. There's a lot of things I wanted to talk about, and unfortunately, the time is so short. Let's do one more improvement to that example, and let's build a pipeline. Now that we know about concurrency, remember I told you to remember that we were waiting for all the requests to complete, and then we printed a table with results. Now that we build a pipeline, these are the two stages of the pipeline. The first one is consuming what to do, then you return responses. The second stage of the pipeline is taking the responses from the previous stage and producing more responses with the most recently pushed projects of a given user. Then I combine together these two stages by creating channels. So I have an input channel, I have an intermediate output channel, then I have a final output channel, and see that this is very similar to Unix pipes. I'm starting two Go routines with Go stage 1, Go stage 2, and the output of the first stage is the input of the second stage. It's a lot like when you do, I don't know, like anything, pipe, anything else in a Unix terminal. And you run that again. Yeah. Luckily, I have my data package running, and we had no problems with internet so far. This is live. As you see, it takes time. But now notice that I was able to perform a lot more. This was a small example, right? It's just a few requests. But I was able to perform requests that are only used to build the second table. I was able to do that in the very beginning because I had this pipeline. So I like the first stage can keep processing input as it comes, and it's in this case I'm building two tables because I did two queries. So it's like a live system. This could be exposed on the web, and it's like it's listening for like you can connect to it via telnet or whatever, and then you're like you can like send, okay, give me the answer for this query, and then it answers you immediately. But then you can give a lot of input. Like, give me answers for this. Okay. And you just perform it not sequentially, but since like, yeah, we don't have to think about async IO in Python, how to do it. No, in Go it's solved. It's gonna use whatever is the best experience in the platform you're compiling your code to, and it's gonna give you all these nice things. As you can see, like there were only there was a response before we built the second table, and there were only two requests here. All the others to build the second table were done much earlier. So, yeah, if you want to write a web crawler, anything else? Yeah. So, a lot more. Like, time is basically over. Interface, I'll just like mention some things that we can talk more. Like interfaces. Man, we like to do duck typing in Python. Here you have statically typed duck typing. So whenever you compile your program, the compiler is able to tell you, yeah, if it possibly works or not. It's not like if maybe it quacks, then yeah, it might work. No. You can make sure that it really does. It really implements whatever you need it to implement. And the cool thing here, like, you don't have to, it's not like Java that you have to say, oh, this class implements this interface. No. Some type to implement this interface, it just needs to have the methods. So for example, if you implement the method string that returns a string, you implement you're automatically implementing the interface stringer. And then the goals format package knows about this, and it will print your struct or whatever your type correctly. So for example, you can use this to print like days of the week in English and represent them as integers. You can say like I have a type that is based on an integer, and I have 1 to 3 to 7, and then I can implement how to print those in a nice way. So yeah, this is similar to the magic methods we have in Python, but I like having explicit interfaces. Doc strings, a lot like Python. Automatic documentation. I can run a tool like go doc, the name of the thing I want to know. Boom, I get the definition. Go doc can work as a server, so I can generate a web page just like we have on docs.golang.org. I can have it locally with all the documentation of all the standard library, plus all of the things that I have installed, maybe with GoGet, all of the packages that I have written myself, everything connected. Very, very good. Testing. Yeah, a lot of people asked me about testing yesterday. Go's approach to testing is also very interesting and very simplistic, very boring. I would love to talk about it, maybe in a different talk, different day. Struct embedding. No class inheritance. Go's focus on embedding structs. And you can like access methods of our embedded struct directly from the parent. So there's a very nice way to do composition, and the language helps you to do that. You really won't miss class inheritance. Mutexes, like low-level primitives for concurrency. And you can use that as a, for example, you can have a counter, you can have a struct with an int and a mutex. So you can then have, you just call like lock, it locks the counter. Then you can increment it, it increments the counter. You can unlock it just by using these two things together. Very cool. As I said, methods, you can have methods on any type. This is amazing. You can have like, yeah, you can build a lot of things with this. Zero values. One more thing that I take for Python, and other languages too. Like in Go, there is no uninitialized memory, and this is the end. Damn, let's talk about zero values later. This is such a great thing. You cannot compile code if there are unused imports. I see a lot of Python code with this. I would add this to the code review thing. Like, when I review code and I see like a lot of imports, half of them are used. You cannot compile Go code with that. People, learn new languages. That's my call to action. Thank you very much for listening.
So I'm afraid we're short with time. So if there are any questions, you can find Rodolfo at his booth down the corridor.
Yeah, I'll go straight to the base stand there. So if you want to talk to me, please. Yeah, I think there'll be no time for questions. Let's talk like in private. Thank you very much.